Hello, welcome back to Cracking the Cryptic. Such a pleasure to have you guys with us again. And such a pleasure to have a blobs puzzle. Now, Blobs sent us this puzzle a while ago, and if I'm honest, I didn't have a go at it for a while because the rule set's quite complicated. I try and keep this slot a little less complicated in terms of rule set normally than Simon's puzzle earlier in the day, just because people sometimes need a bit of light relief when they come here. And understanding a difficult rule set can be a little off-putting for observers, but for new people especially. But I do love a blobs puzzle, so it's worth making an exception. I also like a Galaxies puzzle, and this is one of those. So I'm looking to have a go. Because it's blobs, it might not be the hardest ever Galaxy puzzle. So we'll see how it goes. I will explain the rules fully in a moment. Don't forget that on Patreon we've got all kinds of content, not only monthly Sudoku hunts, but also crosswords and connections and gridogram videos, lovely stuff, lots of crosswords actually. Do check those out. And of course all of our apps feature Line Sudoku, Classic Sudoku 2, the latest one, and worms, and we are working on some new worms, so good news there. Including possibly blobs providing a worm. Now that will appeal. Anyway, let's have a look at the rules of this puzzle because that's what I'm going to attempt today. So let's start with normal Sudoku rules apply. 1 to 9 will go in every row, every column, and every 3x3 box. That's the easy bit. We have to divide the grid into galaxies. A galaxy is an orthogonally connected group of cells that has rotational symmetry about its center, marked with a small dot. All cells must be part of a galaxy and no galaxies overlap. So that would be rotationally centered around this blue, because you could rotate the grid up, or you could rotate the galaxy 180 degrees and the shape would be the same. No galaxies overlap. All cells must be part of a galaxy. Now, in this puzzle, galaxies are either red shifted, moving away from the observer, or blue shifted, moving towards the observer. Don't worry about that. I think that relates to some research Blobs did when he was preparing for the puzzle. And he said it was really interesting about blue shifted and red shifted galaxies, but that is irrelevant. Anyway, the measured value of each galaxy is shown. So for this 18 blob, the measured value is 18. It is the sum of the digits in that galaxy plus the number of cells if it's a blue dot, or minus the number of cells if it's a red dot. Okay, well, we'll work that out as we go. I'm going to leave that bit of the rules up on my screen so I can see it. Dots with a solid black outline, like this one, indicate a Renban galaxy whose digits form an unbroken consecutive sequence in any order. Dots without a solid black outline indicate galaxies whose digits don't form such a sequence. Digits may not repeat within a galaxy. That's important. So the galaxies are like killer cages adding up to a total that we're going to discover, or we're going to discover something close to the total. Oh, there's more though. 5 single cell galaxies, dark stars, are not marked. Their locations must be deduced by the solver. They're single-cell galaxies. All cells, maximum 8, around a dark star belong to regular galaxies. I presume that means non-dark star galaxies. So they're never touching each other. No 3x3 box contains more than 1 dark stars, and digits don't repeat amongst the dark stars. So there's a lot of rules. There's a lot of rules there. But I think if you've ever done a galaxy puzzle before, you'll understand them. And if you haven't, just follow my solve and you will learn about galaxy puzzles and want to do the next one that comes along. Right, give it a try if you do know galaxy puzzles on that first click under the grid. The measured value of each galaxy is the sum of the digits plus the number of cells if it's blue, or minus the number of cells if it's red. Okay, let's get cracking. I have no idea what we're going to find. We're going to find... You see, normally I'd look at this 6 and go, it's a Renban. Oh, I would have said it's a 1, 2, 3 galaxy. Was there a rule that galaxies have to be more than one cell? No. Right, this one is bounded. This one is bounded. Those two cells are clearly part of a galaxy. And that galaxy cannot expand beyond the northern border of the grid, and therefore this cell can't be brought in. And it can't expand beyond the eastern border of the grid, so these cells can't be brought in. So it is limited. That is the full galaxy, those two cells. And they equal 17 minus 2, they equal 15. So this galaxy is made up of digits from 6, 7, 8, or 9. Now, these four are all on this dot that's in the middle of a 4-cell area. Let's make it orange. No, let's make it red. Now, the red dot, oh, it's a Renban one. It's got the black circle. So the red dot indicates... Now, again, we can't expand to the northeast or to the east. So these cells are not in play for this galaxy. The only place it could expand is to that cell, which would be equivalent to that cell. And then it could go to that one as well, which would be equivalent to that one. So it's either a 4-cell, a 6-cell, or an 8-cell galaxy. Now, the rule with the red is we subtract... Oh no, well, we have to add to the 28 the number of cells to get the real total. So it's either 32 in 4 cells. If they're all different, that's impossible. So we must expand. So 28 plus 6 is now 34 across 6 cells. Now, it's a Renban galaxy. Can we make 6 consecutive digits add up to 34? They would have to... No, they'd have to be divisible by 3. How do I know that? Well, if you imagine 6 consecutive digits, the middle two will add to the same total as the two just outside them. If you add, say, 3 and 4 in the middle, they would add to the same total as the 2 and 5 just outside them, and the 1 and 6 just outside them. And that same total would be multiplied 3 times. So this is not a 6-cell 34 Renban galaxy, because one can't exist. So I think it must be an 8-cell, now I'll do the maths on an 8-cell galaxy. 28 plus 8 is 36, and that is going to be the digits 1 to 8, because I know that 36 is the 8th triangular number. And that's fine. Right, this galaxy contains the digits 1 to 8, and it fulfills the Renban rule and the redshifting rule, and that is right. Now we can do something with that. These two cells see 7 of those cells. Just imagine for a moment that this was a 7-8 galaxy. That wouldn't work, because you'd have to put 7 and 8 both into this red galaxy. And the only cell that either of them can go in, that they don't see in the same box or column, is that cell. So this is not a 7-8 galaxy. This is a 6-9 galaxy. Now we still have to put 6 in red. The only cell it can go in is there. And these others are the non-9 cells, or non-9 and non-6 cells. They're 1, 2, 3, 4, 5, 7, 8. So that works fine. Now, this galaxy is stopped from expanding anywhere, so I'm going to give that a color. And that is complete. And this time we're adding 2 plus 2, it's 4. That's a 1-3 pair. Now the 1 and 3 in red, which do exist there, must be in box, whatever this is, box 6. Now, this is a 29 galaxy that can't expand east. 29 plus whatever the number of cells, so it's got to use these cells, and it's got to go further, because that would already be a total of 32, and that's at least 5 cells. So we've got to expand to those cells to keep going. We can't go any further north, and we can't go any eastern cell apart from this one. So we must expand at least to there. Now, we might not be finished. We could do that, and it would still be symmetrical. we're up to now 34, 29 plus the 5 cells, and that would be 98764. Now the 6 would have to go there. Yeah, okay, that's possible and would be quite helpful, but it might expand further. So I need to look at some other galaxy. Right, up here we've got 2 next to each other, one of which is a huge number. So let's make that one color, orange, and this another color will go pink. Now this has to expand, and it can't expand east, so it's got to expand in an orthogonal direction in at least one way. It's got to go north and south. And we're getting up to a total that's at least 47, or, oh no, it can't be. Oh, it's a blue galaxy. 44 minus 3. Well, it's at least 35, because even if this was 9 cells big, it would be 44 minus 9 is 35. That's the biggest cage galaxy we can have. So we have to keep expanding, but we can't go north, and so we can't go south. We can't go to these cells, so we can't go to those cells. So the only place we can expand is to there. Now, it's 5 cells. Can 5 cells add up to 39, which is 44 minus 5? Answer, no, because they're all different. The maximum they can add up to is 35. So we have to expand again, and that's to here. And now we could expand one more time to those cells, but then we would have all 9 digits in this galaxy. 45 minus the 9 would be a galaxy total of... No, 45 plus the 9 would need a galaxy total of 54. What we have instead is a 7-cell galaxy adding up to 37. And that's why this is a 44. Now this galaxy cannot expand. It's completely stuck. It can't go north or through those cells, so it can't use any of these. So this is finished. And this time we're looking at 18 minus 2 equals 16. This is 44 minus 7. This is 37. Ooh, 37. Oh, bother. Does that need a 9 and a 7? No, 37 is 7 digits. It's missing 2 of the digits from 1 to 9. Because we know the sum of those digits from 1 to 9, it's always 45. There's a secret for you. Because we know that 45 minus 37 gives 8, this digit is missing 2 digits that add up to 8. Well, I know it's not missing... I tell you what it is missing. It's missing whatever this digit is. That sees all of the cells in this cage, so it can't appear in the cage. So the 8 must include this digit, the 8 in 2 cells, so that must be a 7. And now we know this pink galaxy is missing 7 and 1. This might be the first of our dark stars, but that might also be an expansion of this one. Don't know. Okay. So 1 is missing from this. So it's in box 2, the 1 must be in one of those cells. 9 has to be somewhere in the galaxy, so that's in one of those 2, because it can't be in this box as well. And in fact, I think this has to be the 1, because whatever digit this is... No, the way to look at it, what is the other digit here? It's not 7, and it's not 5. So it's some other digit. Yeah, it's some other digit. What is it, and where does it go in this box? It can't go in pink again. It's not 7 or 9, so it's not either of those. It's not 1, which doesn't appear in the pink galaxy. Therefore, it's one of these 2 digits, but whatever digit is there can't appear here. So whatever digit is there appears here, and is not 1, because 1 doesn't appear in the pink galaxy, so that is 1. This digit is whatever is in there. Now, we got a 1 into this, and that is going to stop it adding up to 34 in 5 cells, so it's going to have to get bigger. And now we know that it's going to add up to 36 in 7 cells. So it's going to be missing 2 cells that add up to 9. Maybe we can work out what they are. It's got a 1 in. Well, it's missing 2 cells that add up to 9, so it's definitely got a 9 in. That's not here, and it's not here because of the 9 in one of those. So 9 is in one of these cells. It's definitely got an 8 in, because it can't be missing 8 and 1, because it's already got a 1. So there is an 8. It's not missing 1, 8. Oh, it could be missing 6, 3. It's actually very difficult to get a 3 into this region. I think this is the only cell that could be 6 or 3. None of these can be 6 because of that. None of them can be 3 because of the pencil marking here. This can't be 6 or 3. So the only place that either 6 or 3 could go is there, and they can't both go there, so therefore they're both missing. So this digit is not 6 or 3, and they are the missing cells. This cage is made up of 1, 2, 4, 5, 7, 8, 9. I don't know how. Well, then the 7 must be in this box part as well. Right. Well, we're going along fine. Those are all bounded and limited. That wasn't a dark star. Oh, this has got a 1 on it. Well, that must be only 2 cells, surely. Let's go back and let's use dark blue. That is a 1 plus 2 is 3. That's a 1-2 pair. I mean, you can't expand it or you just wouldn't hit the total. 5 in 4 cells is impossible. Right. Let's actually just put in some galaxy centers for everything else, just because we can. I'll make that one red. It's clearly not going to crash into the other red. I'll make that one orange and this one dark blue. That's going to get blocked off from that dark blue, so I could make this one yellow probably. And I hope the 2 yellows aren't. No, let's make this one violet, which I haven't even used yet, and this one yellow. Okay, so I don't think we're going to have any crashing into each other. Now, this is actually in an important place. This can't expand northwards because it can't expand southwards. So this is either a 2-cell, a 4-cell, or a 6-cell galaxy, adding up to 26 minus the number of cells. So it's not a 2-cell galaxy adding up to 24. It could be a 4-cell galaxy adding up to 22. Could it be a 6-cell galaxy adding up to 20? No, because that would have a 9 in it, and these would have to be at least 1 to 5. So that is bounded now. That yellow is complete. And it adds up to 22. This orange, I was going to say it's not a single 6, but it could be a single cell. What is it that red does? Red adds. So it could be a single cell 7. This is a huge number. 49 minus the number of cells. This has to expand. Well, it can't expand north. It can't expand there, it must expand here. Then it can carry on expanding from there in a variety of ways. So I'm going to stop there, but this has got a bit limited. I think this is the maximum extent of this galaxy. It can't go anywhere else. Does it use all of that though, or can it be a bit more limited? I don't know. This one is going to have to expand because 34 is a big number. To the north, it can only go there. So we'll start with that. This would now be worth 34 plus 4, 38. Well, that needs more cells, so we're going to have to go further north. Now it would be 40 in 6 cells. That's too much. 40, the maximum for 6 cells, 987654, is only 39. So this has to expand again. Oh, this has to expand. Let's do that first, because I wasn't sure whether this is going to expand north or east. This one has to expand, because 17 is a big number. And it can only be lateral, because it can't take any cells in row 2. So that must be exactly that shape. Now this one, which was going to have to expand, must expand to there. And that is going to shut off a dark star. Actually, I think this cell has been shut off as a dark star as well, because this can't expand. This one is now maximized at 8 cells. That one was complete. That's a dark star too. So we're beginning to find them finally. There's 5 in 5 different boxes. The first kind of 3 boxes I went through didn't have any. Now, this now adds up to 34 plus 8, 42. The one digit it's missing is a 3. So in this box, one of those 2 cells is a 3. It's either the dark star or this cell. This 12 is going to have to expand. It can't be one cell. So that is going to have, it's a bit like this one. That is going to have to expand this way. And that's complete. This was complete. These are going to have to get in a galaxy. Oh, this red thing's going to have to expand. This is a huge number. And to the south and west, it can only expand that way. So it must do that, must take that cell. Then it must keep expanding, because 4 cells is not going to be enough for this number. So it goes there and there. Now it could do one more, or it doesn't. If it's 6 cells, they are meant to add up to 44 minus 6 is 38. That is not divisible by 3, and this is meant to be a Renban. Look at the black outline. So that is not complete. We're going to have to take that cell as well. It's a full staircase. And now it's 44 minus 8 is 36. This is all the digits except 9 in that one. I wish I had some way to notate this. Anyway, let's just keep going with the galaxies. This is 16 plus 2 at the moment. So it's going to need more. We're going to have to expand it to there. Now it's 16 plus 4. 4 cells could equal 20. Now it might expand further. This has got limited though, and this needs at least 5 cells. This is, oh no, it's 32 minus the number of cells. Could it be 3 cells adding up to 29? No. It's got to be 5 cells. It must be a plus shape. That's the only way it can expand. That is complete. Now this is complete because that place is not available on the rotation. So that's a grey dark star. This one, oh, this green could keep expanding. In fact, the number is huge, isn't it? This is 49. Even if this one became, this has to be an even number of cells because the dot is across 2 cells. If it was 6 cells big, they would have to add to 43. You can't do that. This is 8 cells big, and we know its exact shape. It's like that. That is a rotational galaxy shape. Now, we finished blue and we finished green. We can't leave all of these cells out of galaxies, so 2 of them have to go in the orange one. This is a dark star, and this is our 5th dark star. We have the 5 dark stars, and we finished colouring the grid with galaxies. Now we just have to populate it with numbers. Now, where to start? Right, this is a 6. Not only is it a 6, it's got a black circle. So this is a Renban 6 that has become a 9, and that means this is 2, 3, 4. Now, this is 26 minus 4. That is actually worth 22, but the row is worth 45. So 22 plus 9 is 40. That digit is a 5. This is 12 plus 3. This is 15. So that pair adds to 10. I might be a bit cheeky to just remind myself of that. I'm putting a little X there to show that those 2 add to 10. This one was missing a 3, I remember. 34 plus 8, 42. This is missing 7 and 1. This adds up to 14. 17 minus 3. Oh, what's green? Green is 49 minus 8. This is missing a 4. Oh, well, it couldn't have actually had a 4 in that box or that box. And now we know it doesn't have a 4 in this box. That's actually not very helpful, I don't think. Maybe I'm missing the point. Oh, let's put in the candidates here. 1, 6, 7, 8. That one can't be a 1. That one can't be a 7. These add up to 20, unhelpful number. These add up to 32 minus 5 is 27, including a 9. That doesn't feel very helpful either. Oh, bother. This wasn't going to have 6 and 3, but it has everything else. So that is 2, 4, or 8. This is 2, 4, 5, or 8. I'm not going to know what the dark stars are. How do we progress? This one adds up to 14. Maybe I go back to this red thing. 6, 1, 3, 2, 4, 5, 7, 8. Six, 9, 1, 3. Oh. No, I don't know what I meant to do. Sorry. Am I meant to add up some boxes together? The trouble is the dark stars mess those up because we don't know what they add up to. Oh, this is a bit weird now. Right, 14 there. Can I do that? I need a 1, a 9, and a 7 in the top row. Oh, 7 there says 7 is in one of these two cells. That's just Sudoku. So 7 is not in those cells. 7's in one of these two. 7 is now in one of these two. There's a 9 in one of these three, but I think red couldn't have a 9 in. It adds up to 36, so that 9 is here. That's quite easy, Sudoku, if I'd spotted it. Now, those 3 are going to be the same as those 3. Law of leftovers point. Sorry, I don't find this easy. I got a 9 in a grey cell, so the rule was none of the other dark stars can be 9s. Can that be a 9? If I can say that can't be a 9, what does this add up to? 20. These would be worth 11. No, I think that's okay. 2, 3, 4. There's a 6 in one of those two cells. It's very hard to see the regular Sudoku. 1 and 3 take 3 out of that one. Actually, there's a 3 in one of those too, so that's not 3, and this is 3. And that is just Sudoku. This 41 is going to have a 3 in it somewhere. And that 3 is not in this box or in this box where there's a 3 in one of those. So it's in one of those cells. And now there has to be a 3 in one of these. Can it be there? Then that would put a 3 there and a 3 here. Otherwise it's in one of those two. Okay, I don't know. Two, 3, 4. I feel like I ought to be making better progress. There's a 1 there and a 1 there. There must be a 1 in these cells. This is 2, 5, or 8. It can't be a 4 because that is the digit missing from this region. I don't know. Maybe this one. This wasn't going to have 1 or 7 in it. Oh, those two were going to be a 9 and this digit. one can't be a 2 because of the 1-2 pair down here. That pair adds to 10. This is missing, what was it, a 3. So the 3 in box 1 is in one of these cells. Can the 3 can't be in the dark star there because it would also be in the dark star in box 4. So there is a 3 in this 14 cage, and that digit becomes a 1. So the other 2 digits in this cage add up to 11. They're not 3, 8 or 5, 6, and they're not 9, 2. So this is 3, 4, 7. Well, that's good. 5, 1. This digit is not 7. Not 7. So this digit is 7. 3, 4, 7, 5, 1. This is 2 or 8 because it can't be either of 6 or 9. But we do need a 9 in the top row, and that's in the corner. And these are from 2, 6, 8 and include a 6. Right, well that was good. Now that's a 3 by Sudoku. 3, 7, 1, 9, 5. This is 2, 4 or 8. One of these two is definitely a 4. And what's missing from this? 7 and a 1. Yeah, that's fine. That's fine. That's what we're doing. These are from 1, 2, 5, 8. That digit can't be 1 or 2. That is 5 or 8. And it's another dark star. We still don't know which of these is a 3, even despite what we did. Okay, this cage doesn't have a 9 in it. It has everything else. That could be more helpful than it is, if I'm honest. It doesn't seem to do anything for me. That pair adds to 10. That's still not really relevant. In this box, these are from 2, 4, 5, 8. Oh, look, 6 in this row has only got one spot. There it is. That's a surprise. Now, this can't be a 6, 4 pair, at least now. It's an X pair that add to 10. 3, 4, 7. The 4 there means these can't have a 4 in, and that can't be a 4, and that means this is a 4. That's good. There is a 4 in that group and a 5. Okay, now the yellow runs through these two regions. Oh, it needs a 1 and a 2 in. And they can't be in this region because of that 1, 2 pair. What's yellow missing? It's missing a 3. So it needs a 1 and a 2. Oh, that's very straightforward. So this is an 8, 9 pair. That digit is 8. No 8 in those cells. That digit is 8. No 8 in those cells. Oh, well, this got going. This is now a 5 in the grey, in the dark star. This has now had 1, 2, 6. So these are, we need to put a 6 in this box, and it can't go in yellow, so it goes there. And that means the dark star is the 3, which can't go in the yellow area at all. Now, this can't be 3, 7 or 6, 4. It's either 1, 9 or 2, 8. In this column, oh, that's 6. We need a 6 into one of those two cells, and it can't be in the red galaxy again, so it's there. Now, one of these is a 3. These two are not 3s, and that is a 3. Now, one of these two are 1s. Okay, these two, I feel like this galaxy needs a 2 in it. It adds up to 41. It does. Oh, but that 2 could be here. And I know it can't be in that box. Have these got narrowed down? That can't be a 6 anymore. No, they haven't got narrowed down very much. It's annoying that this is not resolved, but the 1 and the 2 in the column are both going to be used in those cells. That doesn't do anything. Right, this cage, 8, 1, and then these digits are, what was missing from this region? I can't remember now. 29 plus 7, 36. It's missing 2 digits that add to 9 that are 6 and 3. That's what's missing. So these are 2, 4, 5, 7, 9. And they all see that cell, which must be 8. Now, the 8 in this region is not in green and must go there. And that makes this one a 7. And now these can't contain 7. 8, 7, 3, 9, 6. One of these is 1. Okay, surely that 8 was going to do more. 8 in books. 5 is in one of those 2 cells, but that's red, so these can't have an 8 in now. Now, I still haven't worked on this one, which adds to 27, or this one, which adds to 20. Haven't really thought about those totals at all. 8 sitting there means that can't be 8. Now, what's this? And does it go in green here? I think it does. Because it's not 4, which is the digit missing from green. Because 4 is in one of those cells. So whatever it is, has to be in green in one of those 2. Oh no, this could be the 3, couldn't it? No, it couldn't. There's a 3 there. No, whatever it is with the 3 there. It's not 6. Oh, hang on, I can't repeat 6. It is 6. Oh, it's in one of those 3 cells. It is 6. That 6 can't repeat in green, so this is 6 by Sudoku. So these are 1, 5, 9. That's all I've got left in the box. 8, 6, 7. These are 3 and 2. There we go. Now, what about 2 then? Okay, 3 and 2 are both needed in this red area that doesn't have a 9 in. So they must now go there. That's not a 2. So now we've got this as a 1, 9 pair. That fixes 2 and 1. This is not 1. 4 is in one of these 2 cells. I don't know if that's any use. 1 and 2 there resolve the 3, 2 pair. That's not a 3, so that's a 3. That feels a bit like this region. Down the first column, 2, 6, 3, 1, 9, 5. That is 4 or 7, and this is the only place for 8. That's fixed where 8 is in the central box, which is here. And this column, maybe, 1, 6, 7, 2. That digit is 1 or 6. This one is 1 or 7. This region has got 2, 3, 6, 8, 4. It needs 1, 5, 7. I can't do those yet. That 2, 6 pair I can do. That 2 fixes this pair. Now, down this column, 2, 8, 1, 6, 3, 9. These are from 4, 5, 7, and they include a 4. And this region, which I know adds up to 27, now has a 9, a 6, and a 4 in it. And they add up to 19. So the other 2 cells add up to 8. They're either 5, 3, or 7, 1. This digit can't be a 1 because we've got a 1 in row 7 and 8 there, and a 1 in row 7 and 8 there. So this is a 3. If my maths is right, this is now a 4, 5 pair. That digit is a 7. That finishes the central box. 1, 5. I mean, I find this puzzle quite complicated, if I'm really brutally honest with you. Now, there's a 1, 5, 9 triple there. That's huge. That means I can write in 6, 4, 8. Now, that's not 8, and that's not 6. And that, we finish off the yellow region there. This box needs a 4 and a 7. Now, I notice a pair. Okay, that doesn't really do much else. This region was going to have 2, 4, 5, 7, 9 in it, if I remember correctly. 7 is placed there. Okay, this row, that can't be 1 or 2 because of the pair in the box. And that must be 2. That's good. That now can't be 2. The 2, in fact, in the column fixes the bottom 2 cells. Then I can finish column 7 entirely. and box 9. Now I must be able to finish column 1, I would have thought. Oh, maybe not the 4, 7 pair. That's now 4, that's 2. 4 and 9 here, they're done. 1 and 5 here, they're done. A 5 here, 7 there, and this is 9. I can do 4 and 7 at the top, and then I can do 4 and 7 down here, and there we go. That is our Doppler astronomy completed. Fantastic puzzle by Blobs. Great fun, very interesting stuff. And I hope you had a go at that and enjoyed it. I wonder if it's a slightly overcomplicating rule with the blue and the red, but Blobs did want to draw our attention to the fascinating phenomenon of blue shifted and red shifted galaxies, and he's done just that. Thank you for watching, and I hope to see you again soon on the channel. I've indulged myself today with a slightly complicated puzzle in a style I really enjoy, and I hope to see you again soon tomorrow. Bye for now.